Derive the quadratic formula. So we're going to find all zeros of this quadratic function. F of x is equal to ax squared plus bx plus c. And we're leaving our a, b, and c generalized. So basically, we're going to be finding the zeros of any quadratic function. The only stipulation here is that a is non-zero, because if a were 0, we wouldn't have a quadratic function. So we're solving generally. So there's going to be two parts to finding the solution, the general solution. The first is we're going to take this function f of x, and we're going to convert it from standard form to something that looks more like vertex form to make it easier to solve algebraically, and then we're going to solve it algebraically. So remember, the first step, whenever we're trying to find the zeros of any function, we're trying to find what input values give us an output of 0. So always the first step is to take your function and to set it equal to 0, which I did here in step 1. So we set our function equal to 0, and then because I'm going to be doing a little bit of completing the square, converting to vertex form. In order to do that, I need an a value of 1. So we don't know what a is. A is some constant real number, but as long as it's non-zero, I can divide both sides of the equation by a, and it's fine. So that's what I did here in step number 2. I just divided through by a. Next step, we want to isolate the constant on one side of the equation and leave all of our terms with variables on the other side of the equation. So I just subtracted c on a from both sides. Then comes the completing the square part. A little bit tricky, but basically we just take the coefficient of the x term, so whatever number, which b is a number, a is a number, b on a is a number, whatever number is being multiplied by the x term, we're going to divide that by 2, square the whole thing, and then add that number to both sides of the equation. So when I take b on a, I divide by 2, I get b divided by 2a. When I square it, I get b divided by 2a squared. This is just a number that we're creating in order to be able to make a perfect square out of our terms of variables. Just standard completing the square. It just looks a little bit different because we're not dealing with numbers, we're just dealing with variables. So completed the square, and you can, check for yourself if you want. This thing here, if you multiply, FOIL it out, is going to be equal to this thing. And you've done it properly, that you've properly completed the square, that you've picked the right term to add to both sides, if you can turn your terms with a variable into a term squared, right? So we've got the term x plus b over 2a all squared on the left-hand side. On the right-hand side, we've got the rest of our constants. And that's what we're going to do in step number 6, is deal with these constant terms on the right-hand side of the equation, clean it up a little bit. So kept the left-hand side of the equation the same because we completed the square. We're done with that for now. And I just did a little bit of algebra to make this look a little bit nicer. So, expand b over 2a squared. Then I found a common denominator of 4a squared and added those fractions. So if you know the quadratic formula, it should start looking familiar. So now that we've cleaned up the right-hand side of the equation, we're going to take the square root of both sides so that we can eventually isolate x on one side of the equation. Recall that although squaring and square rooting are inverse functions, when we take the square root of a squared number, we don't get when we take the square root of x squared, we don't get x back because we have a domain restriction on the square root. So when I do these operations in succession, I get the absolute value of x, not just x by itself. And because of that, I have to count for that domain restriction. Because essentially what I did between step 6 and 7 was just, take the square root of both sides. So to account for that, you gotta add this little plus or minus symbol. That's just accounting for the fact that you get the absolute value of x when you do those operations one after the other and not x itself. So Now that we've dealt with that, got rid of that square, step number 8, we're going to simplify a little bit more. So this right-hand side of the equation, I just split it up. So whenever we have a quotient or a product and we take the square root of it, we can always kind of break each of those off into their own individual square roots. So that's what I did here in step number 8, just to simplify a little bit more. I broke the numerator and denominator up into their own square roots, and then I simplified the denominator down to 2a. Now all we have to do to solve for x is to get x on one side of the equation, so subtracted beyond 2a from both sides. And finally, because we have a common denominator, all I got to do is add those fractions together, and this is the final result. So this is the quadratic formula. It's a generalized solution, so the zeros to our original function f of x can always be found by plugging in the a, b, and c values into this formula.